Welcome to part 7 of my Wolves on the BackBit series. We are at day 23 of the project now, and my job is, the current task at hand is make the Digi play without hitting any of the bad lines. Now, the day before, although I don't have any footage of it, I was hard at work. So day 23 begins with something that doesn't work and ends with something that does. And even though I did go on to refine what I come up with even further in the times following, but in one day I still came up with something I am quite proud of even a year later. It's an elegant solution to what was a rather troublesome problem. This day was one of the most satisfying and frustrating experiences all in one. Because, unlike the sound, where you're just trying to make something that has a certain amount of static have a little less static, it's hard to tell. I mean, you think you got good ears, but they don't work that well. And at least with what I'm doing on this day, I can add coloring so I can see when the NMI comes in and when it leaves, and it makes things a lot easier. I don't even have to listen to how good the water tastes, not even once, even though this is all audio related. So yeah, it's just about the NMI interrupt starting and stopping and getting that sucker to not strike on a bad line. What fun! I really, really did enjoy this day. Um, what else to say? Not much, I guess. The clips speak for themselves. It tells a story almost. It's kind of neat. I'm rather proud of just I don't know what this particular part 7 is. It's to me. I mean, I gotta obviously watch this stuff as I make it. This is rather interesting. Hopefully, not just to me, but to you. Um, yeah. So let's get to it. And this is the last of the sound by itself problems. After this, we are into what I call the combo player, where I'm trying to weave the video and the audio together. That's next part. This is the last of the audio stuff, and yet it ends on an interesting note. So let's get to it. Bad line avoidance. Let's watch.
After a lot of work, I'm down to the part where I think I can adjust the timing. I'm messing around here. The white is the beginning of the NMI. As you can see, the bad lines definitely affect things. That's what I want to stop. I want everything to be close to one edge. Actually, I'm not taking out the ROMs here, so it's got to do, pushing stuff to the stack and all sorts of nonsense before it actually gets to my code. So I'm still adjusting it with that in place. Ideally, you would take the ROMs out. In fact, at the beginning, I did, and I thought it'd be safer to leave them in. So let's see what I can do with the ROMs in, and then probably take them out at the last step. Who knows? Got some interesting effects happening as well, but this isn't what I want either. Still trying to tweak the timing. I don't understand. If I have it set to trigger what I believe is the equivalent of every odd line that happens before a scan line, it should be out and done before before a bad line hits, that is, not a scan line. So why is this stuff happening here? Why is it still, like, at the beginning it changes the color, does some stuff, changes the color back, and then pretty much heads on out. But why this? Why? I don't know. I've already got rid of the double raster interrupt nonsense. It's just checking DO12, adding a delay, and then starting the NMI when I believe it's the right time, although I'm tweaking it. The double raster interrupt trick that demo coders use, I guess, was Crash City for me. I couldn't reliably get on it. As it is, this crashes occasionally just restarting it, and I believe I'm careful, so I don't know. And of course, if the screen is off, well, everything happens pretty much as expected. Now you see how it's kind of on a line and then kind of blurred together, kind of on the line. I think that's a sad side effect that I'm using an LCD monitor. This is actually a very old Sharp Aquos TV from, I think, 2004 maybe. I can't remember. It's only 640 by 480 pixels, so it's one of the early ones. However, it works quite well for this, with the exception that it's now faking scan lines when it doesn't need to. A real monitor wouldn't have this problem. I have one kicking around, but of course it's obviously deeper. I only have so much desk space here, Still running some tests. 0 is what it defaults to when it's already incremented something. I just put it back to 0. So it's not counting like multiple occurrences of 63 over and over. But anyway, how did I end up with 129 there? That's what the frequency gets reset at. And yet, upon entering the NMI, it was able to read that value of 129. How did that happen? I also have a little bit of code that caps these at the 255th page, so it won't wrap around and look bad. But interesting, but I still don't get it. In the end, it doesn't sound much different, but for my OCD-ness, I would sure appreciate it to happily dodge over every bad line. Now here's the question. When a bad line occurs, the CPU is stunned. Yeah, stunned from doing stuff, but is the clock still ticking? Is the NMI timer counting those clocks? If that's the case and the clock isn't ticking, then naturally the NMI gets delayed by that many cycles anyway. Now a way to test if this is true, play my sample, time it with the screen off, time it with the screen on. Yes, that should be one way to find out. Let's do it. I think something I might try first. I have this, let's see, where is it? It's somewhere above. I have Y set to 11. So after my wait line, I can start the timer immediately. However, the frequency I don't set until after. I'm going to change these lines so they squeak in here, get rid of those ones, see if that makes a difference. If that's all it took, man, am I stupid. Well, it didn't fix the problem, and I'm still fiddling with the settings before I do my timing trick, but look at this. Neat. How are you seeing only one dot? I thought that was screen, character cell wide. So a single dot shouldn't be appearing there, but that's kind of cool. Don't know why that is. Here's one of the more perplexing issues. I shuffled the screen up by one line, and yet, for some reason, the scan line before the supposed bad line, unless that is a bad line, the scan line before is the one that is completely stalled here. Interesting. Do I misunderstand scan lines? I thought they happened on the first of 8 rows of a character, of a new character. And as the beam gets to the P at the very top row is when it's fetching the value for that and that and that. Or does it happen the line before? No way. I don't know. This is driving me nuts. Yeah, it's me again. I think I figured it out. This actually is a bad line because in order to fetch these characters properly, when it's there, it still has to be reading them. Duh. That makes sense now. I understand it. But how is it just, I don't know. How can I deke out these bad lines altogether? It's a good way to see my bad line occurring, though. I like that. See, here's another interesting oddity. I'm skipping my bad line. It's not trying to do it, but on the next line, it's happening early. Why? Oh, so confusing. Okay, I gotta stop breaking and to tell you the news that I have bad news. Another interesting whatever. Make of that what you will. Okay, this time I'm just running it through for a few seconds to get some data on the jitter reduction again. So notice all the jitteries. Let's see if I can reduce that. And my jitter reduction doesn't seem to have done a thing this time. And I wonder if that's solid black chunks or interrupts interrupting interrupts. Man, this is so crazy. Okay, I'm on to something. Check this out. We will put just one delay back. I've been fiddling with this. Oh wait, can't just, yeah. So you saw what it did before. Ah, for fuck's sakes. See, sometimes that. Which is kind of what I want. Look at this fluke. Wow. I just happened to remove or add an extra delay. Ran it a few times, but you see I have it. Oh, no, now it's not responding. Crap. While I'm no longer fetching the timer, I'm getting the raster line, throwing it into my little counting array. And, you know, by the looks of things, all the raster lines are being hit equally. And obviously these ones are getting hit more because that's on the last few rows of the screen where the 9th bit is set. But my book, there are 262 horizontal lines on the NTSC. So why is this going from 0 to 255 and then from 0 to 6? Now, well, something doesn't mesh. What kind of system do I got here? What is this deal? Yeah, I don't know. What I can do, some more digging around, but possibly have it watch for a certain raster line and skip it. That way the bad lines are not going to be actually intentionally nailed every second frame of the screen, which I think is what might be happening here. That is weird. Everything's weird until you understand it, and right now I don't, so back to the internet. And I have 263 rows. Oh, you're kidding me. Everything I've been doing for like the last 2 days was assuming I was happily skipping over every bad line, but in fact every second frame I was doing them. Ay, ay, ay. Well, that's good news. It's bad news. I'll figure out how to get around this. Check it out. Let me switch the DO20s to DO21s. Be right back. And there you have it. What I'm doing is looking for, what do we got here? Set it to black, check the raster line, save it. Well, compare with 0. Yeah, well, never mind. If it's anything but 0, proceed as usual. But if it is 0, we check, are we on the bottom half of the screen? If so, we go here, waste time. Now, I was going to put in a bunch of knobs, and I realized that didn't work. I already tried it. Well, I do have knobs now, but I stopped the timer for exactly 65 cycles and restarted the timer. It was that simple. And that makes sure that what is dodging the bad lines on every even frame is now dodging the bad lines on every odd frame. Whether that sounds better or not, well, I haven't even listened to it yet because, I mean, yeah. But wow, and you can actually see, what my monitor is doing. Before it was blurring together because actually that was pretty much every single line it was drawing on. Yeah. Debugging is fun. And of course, once I get rid of the fluff, like once I have the sound and the timing fine-tuned, if I try, I can get rid of, well, the coloring. So that's, 8 cycles or 9, 10, 11, 12 per sample. But if I want this to work, I'm going to have to keep some version of this in play to watch for that. And, that's if, in fact, it sounds better without the bad lines. Okay, done. Looking at my code, one way to refine this later, well, this would be gone, this would be gone. This will still have to be here, but what we can do is compare it to some value below the screen, but yet not in the the 9th bit. So say load, compare to say, I don't know, 252 or whatever. And if equals, take off, do the delay, leave. So it'll fall through faster and we won't have to load a secondary number, all the time. In fact, doing this, even if it's, well, you get the gist. Okay, cool. And this is what happens if I remove just one of the knobs in my delay where I'm stalling it for 65 cycles, like with the timer off for the NMI. So you can see, poof. And if I add a delay, it's probably going to go in the other direction. Let's try that right now. Let's see here. Sorry, you get to stare at nothing for a while. There we go. I bet you it's going to go to the right. Oh yeah. So you can see with the way I have it now, I have an ops and then a single 0-page load, so for 3 cycles to add up to 65. And that's it. Of course, I turned it into a subroutine just to keep it out of the way, but yeah. I can't wait to get this sucker done. I want to get back to the video part. This audio is getting boring. Well, you can see from my raster line occurrence count, where 0 doesn't matter, but it works, skipping supposed bad lines on the first 256 lines, but here it's doing 1, 3, and 5. Weird. And of course it's doing 4 and 6 also, so every other frame it's running the odds, the evens, the odds, the evens on the second part of the 9-bit raster. Weird stuff. Maybe I'll try to fix that too. Sometimes it still happens on an odd line. Very rarely. Now I wonder if that's like a super rare event where it's queuing up another, the audio bank is wrapping or something. But still interesting. Sorry. Here's something I also noticed. You see this jitter pattern? It's very little and then there's a lot. Now watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's not the BackBit's fault because this is the part where I'm doing this. This instruction, it's a lazy loop, but I'm fetching data from the BackBit at that point, and that instruction takes 6 cycles, right? Now, so what I did here, I skipped chunks of my main loop here. That increment, like this, is just busy counting. That's a 7. These are 6s. There's a lot of expensive cycle thingies in here. But if I take these out, let's do that while you're still here. We'll get rid of that one. Let's see here. Like even the subroutine I was doing all the time, right? But, well, I'll leave that in. But anyway, so we have this now. And instead of this, we're going to go back to big loop again. And now watch. I mean, it's not likely that you're going to write an entire program without using these more expensive instructions, but watch the jitter. See, it's more constant. And that's because the NMI is forced to allow certain instructions, longer instructions, to complete before they do their thing. So if I wanted to be really careful, I could avoid using the 6 cycle instructions, the 7 cycle instructions. Use adds instead. I mean, that's being a little anal, but in here, where was it? Oh yeah, as you can see, I switched it all around. Before it was just, oh hey, this is bad. I can't believe I have that in there. But, wow. I was supposed to be using the accumulator only, right? And that's why I'm saving it and restoring it. But before, it was just the X. X was dedicated to the NMI alone. So I didn't have to save it. I didn't have to restore it. And as a very high price of not using X in my program at all. But you and I just found this one. Yikes! I don't know what I could have been screwing up. Oh, that does make sense now, because I might have already shown you an image at this point where, for some reason, number 129 was coming up a huge amount, but 129 would be this plus that. The acknowledgement. Wow. Everything has a reason. That's the fun of debugging. It's like, it just does what it does, but do you know why it's doing what it's doing? And once you know, it all makes sense. But until then, it's a freaking puzzle, isn't it? Okay, back to work. The audio is actually playing right now without the screen obviousness. But something to check out. See these two values? The one on the left is the current audio buffer being accessed or filled. And the one on the right, because of how I ended up skipping the increment that happened every time, it only increments it when the audio is filled. So the value on the left and the value on the right, you see there's a delay in the change. That delay is exactly how long it takes to fill the audio buffer. So the audio buffer is like the demand and then the satisfaction. That's how long it takes to fill. I'm currently running, I think, what is it? Not 16, 4 kilobyte buffers. Yes, I think so. Yeah, whatever. And I'm figuring out, how much free time I have so far. Obviously, more work needs to be done, because how do you fit 155 seconds of audio or video compressed in here? I need more cycles, of course, but I know I can slim down the copy routine and tweak things in certain ways. I don't need to remove the saving, the push and the pull of the accumulator in the NMI, because say 1.2 million accesses times 7, that's what, 8 or 9 seconds worth of processor time overall. And the price to save those 9 seconds is not using the X register anywhere in your program, which is kind of dumb. So yeah.